Sorry. So, proportions. The first thing you need to identify in a proportion is a ratio. We talked briefly about ratios last week when we were doing the Khan Academy notes. Who can explain to me what a ratio is? Who can remember from last week, all the way from last week, what a ratio is?
Like comparing.
Yeah, it's a comparison of two numbers. So a ratio is a comparison of two quantities, two numbers, using a fraction. Now, there's three different ways that you can really write a ratio. So there are three different ways that you can write a ratio. One of the ways is a fraction. So if we would compare females to males in this class, how many females do we have? How many? We don't count? Okay, so 5, not counting staff. And then how many males do we have? Okay, 5 to 6. So 5 females to 6 males. That's one way we can write a ratio. Another way that you can write that ratio is 5 to 6. Then the last way, the way that we're going to be dealing with is writing it as a fraction. So we'll write it as a fraction, 5 over 6. So we're going to be doing ratios in fraction form. Okay? Now, a proportion then, a proportion is when two ratios are equal to one another. So a proportion is when two ratios are equal to one another. Okay? So, determining if two ratios are proportional. Two ratios are proportional if what? So, two ratios are proportional if, if they're equal. So, that one you have to write in. So, if they are equal to one another. Which is basically if they are equal. So two ratios are proportional if they are equal. Now what does that all mean? So let's look at example number 1 to figure out what I'm talking about here. So you're given two ratios here. You're given the ratio 3/4 and 6/8. Now, there's a couple of different ways you can determine if this proportion is equal or if these ratios are proportional. The first thing, since they're in fraction form, the first thing you could do, or the first method that you could determine if they're proportional or not, is to simplify each fraction. Is 3/4 in simplest form? Is 3/4 in simplest form? Yeah.
No.
What about 6/8?
No.
No. So we can go ahead and simplify 6 over 8 by 2. Good, Nick. So 6 divided by 2 is what? 8 divided by 2 is 4. So when we simplify 6/8, are these two ratios then proportional? Do they equal one another? Are they the same? Yes. So these two ratios are proportional. So we just simply put the word yes and box it. Now, as I said, that's one way. If you don't like to simplify fractions, like I don't, another way you could see if these two ratios are proportional is by taking them and cross multiply. So we talked about cross multiplying last week. So I take 3 times 8. What does 3 times 8 equal? And then I would take 4 times 6. What does 4 times 6 equal?
24.
Are those the same numbers?
Yeah.
So are these proportional? Yeah. So two different ways that you could determine if ratios are proportional. I'll leave it up to you which way that you prefer to do. When we solve proportions, though, you're going to have to cross multiply. Okay, so that's example number 1. Let's take a look at example number 2. Now again, two ways that you can determine if they're proportional. The first way is to reduce each ratio. So looking at 20 and 44, what are both of these numbers divisible by? 2. What's another number they're probably both divisible by? 4. So let's do 20 over 44 and divide them by 4 to see what we get. So what's 20 divided by 4? Okay. What's 44 divided by 4? Okay. Now let's go to my other ratio, 24 over 40. Now remember, your calculator can simplify them for you. I don't have a calculator, so I have to work it out longhand. So look in here, what's 24 and 40 both divisible by? Okay, so what's 24 divided by 4? What's 40 divided by 4? So, can 6/10 be simplified further? Okay, what are they both divisible by again? 2. So what's 6 divided by 2?
3.
What's 10 divided by 2? Okay? So when I reduce my fractions here, I end up with, or my ratios here, I end up with 5 over 11 and 3 over 5. Are those the same numbers?
No.
No. So are those ratios proportional? Are they equal? No. Okay, so that's probably how I would have done it if I was doing my homework assignment sheet. I would have cross multiplied like Isaiah said. So Isaiah, when you cross multiply 20 times 40, what'd you get? Okay, and then when you cross multiply 44 times 24, what did you get? 1,056. So again, are those numbers the same? No. So it gives us the same answer, that they're not proportional. Those ratios are not equal to one another. So which way do you rather, how would you rather determine if they're proportional? Cross multiply or reduce?
Reduce.
All right, bless you. All right, let's take a look at the back side. So, solving a proportion. Again, we talked about this briefly last week. When you're given a proportion, in order to solve that proportion, what must you do? How did Isaiah determine if those two ratios were equal? He cross multiplied. So when you are solving a proportion and you're trying to find a missing number, you're going to have to cross multiply. When we cross multiply, we're going to get a equation with a variable then that we solve for. So you can just put cross multiply for now. All right, 4 more example problems. I should have stopped by Starbucks for all of us this morning, huh? All right, example number 3. So this time, I'm given the ratio 2/3 equals A over 6. I want to determine if these two ratios are equal, proportional. But I can't just simply cross multiply and put yes or no because I'm missing the value of whatever the variable A represents. So, nope. So what we're going to do, we're going to cross multiply and we're going to get an equation. So we're going to cross multiply. It does not matter if I do 3 times A first or if I do 2 times 6 first. I always like to go from top to bottom, so that's the order that I'm going to go. So I'm going to take 2 times 6 and get 12. Then I'm going to multiply 3 times A and get 3A. So 12 equals 3A. I just cross multiplied. From here, we're going to go all the way back to first triad when we're solving one-step equations. So the first thing I need to do, circle my variable, draw my line of equality. Then, there we go. So then I bring down my A. 12 divided by 3 is 4. So they're saying the value for A is going to be 4. Now, what I'm going to write over here in the red, you guys don't have to write. But I just want to show you then. So if I have the ratio 2/3 equals, what am I substituting for A? 4. Over 6. Now let's see if they're proportional. So I'm going to see if they're proportional by cross multiplying. What's 2 times 6? What's 2 times 6?
12.
What's 3 times 4?
12.
So do the ratios end up being proportional once I solve for the variable A? Yeah. You don't have to do, like I said, what I did in the red there. You just have to solve for the variable and the proportions. All right, let's take a look at example number 4. Solve for the variable. So again, I'm going to cross multiply. So when I cross multiply, Joey, what am I going to do first? Okay, and when you take 20 times 12, what do you get? Okay. Then put my equal sign. What's the next thing I do, Joey? And that equals? All right, from here, Devante, what do I do? And then, all right, from here, Brendan. What? Wait, huh? How'd you get that? What'd you do? There we go. So divide each side by 24 to get the variable c by itself. Then c equals, again, 10. So if I would substitute the number 10 for the variable c and cross multiply, these ratios would end up being proportional. They would be equal. Yes?
So we gotta do it. We gotta substitute it.
Yes, sir. Next year, when you guys get into geometry, are you guys going to feel freedom when you don't have to circle your variable and draw your line of equality?
Yeah.
Or are you going to still do it anyway because it makes your work look nice and neat?
Yeah.
I guarantee you some of you will do it anyway. It'll be habit. Okay, example number 5. Like at this point, I say it so many times throughout the years and throughout the day that I almost say it in my sleep. All right, example number 5. Oh my goodness, what is wrong with this one? Whew. So it's going to be a little bit different, right? How many step equation are you going to end up with?
2-step.
Yeah. So we're going to follow the same exact steps as what we've previously done. So we're going to start off by cross multiplying. Now this is where it's going to be a little bit different. So when I go to cross multiply this time, what do I have to make sure I do? What do you think? Say again? Louder? I bring the 5 with it, but does that mean I'm going to multiply the 2 with the 5?
No.
Yeah. Okay? So when I cross multiply, I have to multiply it by every number or every variable. So I'm going to take 2 times b and get,
2b.
okay? Now, I'm going to take 2 times positive 5 and get, no, I'm going to take 2 times positive 5 and get what?
10.
Yeah, plus 10. I thought you said 10b. So basically, this here looks like this. It would be like this. Okay? Do you guys remember how to distribute? How you do 2 times b is 2b, then 2 times 5 is 10? You could actually even write it out like that for that first step if you want to. I just skipped that step and distributed it without writing the parentheses. Thank you. So, your choice. You could go ahead and write it out with the parentheses and then distribute, or you could just distribute it all in one step. Okay? So then we cross multiply our other numbers. So what's 3 times 6?
18.
18. Now, Rihanna guessed correctly. When I asked how many steps of an equation we were going to have, we're going to have a 2-step. We have 2 numbers we have to get rid of in order to get the variable by itself. Now, you can't just pick any random number to get rid of, right? We're going to have to use PEMDAS. But how do I use PEMDAS when I'm trying to get the variable by itself? Remember PEMDAS, order of operations? How do I use it? SADMET. I do PEMDAS backwards. So, which number would I get rid of first? The 10. How do I do that?
-10.
So then I bring down my 2b equals 18 minus 10.
83.
All right, there's one step. Now what?
Divide by 2.
Divide by 2. So then b equals, was it equal? 4. Too easy for you? Is that what you're mumbling over there?
Tell what?
Did you say, are you mumbling that this is too easy for you?
It is easy.
Good. Tell me that on Wednesday.
Okay.
Maybe for real, it's gonna be hard. Maybe.
No, you know what, you guys? It isn't going to get much more complicated than this. Okay.
What's Wednesday?
When we do word problems.
Oh.
It was hard. The second
hate
grade
war
because Mr. Ockney was not explaining nothing.
Okay, so again, you don't have to do this, what I'm going to do in the red over here, but I just want to show you what it looked like then. So we have 2/3 equals 6 over, what do I substitute for my variable b? 4 plus 5. Now, before I go to solve that, I'm going to go ahead and take 4 plus 5. What's 4 plus 5? 9. And then I cross multiply to see if they're proportional. So what's 2 times 9?
18.
3 times 6? So yes, our ratios are proportional after we solve. All right, you guys ready for the last example? Now again, I mixed it up a little bit on you guys once more. This time it says solve for the variable. However, you're going to end up with a decimal, so you're going to have to round to the nearest thousandth. How many place values past the decimal to the right is the 1,000th place value spot? Think about it. How many places past the decimal are we going to round? 10th, 100th, 1000th. So 3. You held up 4, I thought. I switched it on me. All right, so we're going to cross multiply. So d times 7.
70.
Thank you for not saying d7. 7d equals 5 times 6 or 6 times 5?
6 times 20. Whoa.
30. There we go. Circle my variable. Draw my line. How do I get the variable by itself?
Come on, Bus Eddie. It's not even so.
What do we get? 30 divided by
2857.
4.2857.
2857.
14286. Right? You guys get that in your calculator? How many guys are lazy and just counted on other people to do it for you? Uh-huh. So, which number is in my 1,000th place value?
Seven.
Which number? 5. So I can get rid of all the numbers behind it. I look directly to the right of that 5. Is the number to the right of it 5 or bigger? So what happens to the underlying number? How many guys are going to remember to do this on your paper correctly? I heard lots of mumbles on that one. Okay, that's it. That's all solving proportions is going to look like. Good. So I want to see all A's on the quiz on Friday.